Hi everyone, I hope you're doing well. I'm Bharat Jain and welcome back to another series of the ROS-MCP server tutorials. In this video, we will be looking on how you can control your ROS-operated robots from the ROS-MCP server using your N8N workflows and automations. In this video, it's the first part of the series. We'll be looking on how to set up the ROS-MCP server for a streamable HTTP request. And then we'll see how to set up your N8N workflow where you can connect the ROS-MCP server directly from N8N to your local computer, and then from your local computer to your ROS operated robots running locally. Alright, so let's get started. So as you can see that this is the N8N workflow that I have, and this is essentially just taking a chat message and then using the OpenAI chat model and along with the MCP client. And this is a virtual machine that's running on my MacBook. Right now I'm using Ubuntu 22.04 along with ROS Humble. So the very first thing that you need to do in order for you to connect the ROS-MCP server, which is running locally on your computer, we need to allow port forwarding for N8N to start communicating with a ROS-MCP server that's running locally. So the way that you can do it is using by a service called as ngrok. So this is ngrok. You will have to create an account in ngrok, and then you'll have to install ngrok as well. So as you can see that I have selected Linux and it comes in different parts as well. And then you'll probably have to copy the commands that's been given, and then you can just paste them simply on the terminal. So I did the same. In order for you to verify your installation, just mention ngrok, and as you can see that the installation is now available. So the next thing that I need to do is that we need to generate an authentication token for ngrok. So for this, go to your ngrok account and go to your authentication, and then it will give you authentication token that you'll have to copy. Well, once you get this token, make sure that you copy the authentication token, come to your terminal and use this command which adds your authentication token to the configurations of your init file. So I'll just do the same, and as you can see that it has been saved to my config files. So now I'm ready to start use ngrok. This will start forwarding the port from ngrok to N8N. I can use their URL for domain forwarding. In order for me to do that, I'll simply go ahead with the command ngrok http 8080. So this forwards the 8080 port over to internet. So as you can see that this is now forwarding my local host 8080 onto this particular URL. Okay, so that's great. Now the fact that I will be able to make the ROS MCP client communicate with the ROS MCP server, because N8N can directly publish commands on this URL, and then they will get forwarded to my local host, and then the ROS bridge will take over from there, and the ROS MCP server will then communicate the commands over to the robot running on ROS. All right, so that's great. So now let's go on our N8N and just look at a workflow. So the workflow is very simple, and what it involves right now is I've taken a chat message. So this chat message is being taken from the N8N interface itself, and then I've connected an AI agent node. With this AI agent node, so as you can see that I've connected an AI agent node, and I've set the max iterations to 20, because sometimes you might have a longer step executions, and you can obviously change that as well according to your need. And then I've connected the OpenAI chat model with this, and you can connect and you can get your credentials from OpenAI account. And then I've used the model O3 Mini. I've seen that this sort of performs better in terms of tool calling and being able to work in longer term tasks than other models. So you can also play around with different models here, but for the purpose of this video, I've used O3 Mini. And this is the tool that you need to use. So you can come on nodes, and then you can search for MCP client, and then you'll be able to find the MCP client node, which you have to connect to the tool section. And here you'll have to select the server transport as HTTP streamable, and you'll have to put the endpoint as the endpoint that you've gotten from ngrok, and make sure that you mention /MCP, because then it communicates to the WebSocket directly. Make sure that you do not have any authentications, and then the tools to include are all. All right, so that's great. So one thing to note is that we can use the json.chat input as our chat input for the AI agent. Once you've made this connection, whenever I send a chat request, the OpenAI chat model will be able to communicate and have the tools for the MCP client, which will be operating over to my computer. So I have this. Now make sure that you start this, and in a new terminal, so I'm using TotalSim. So I will start TotalSim, and I will start this TotalSim node. All right, so as you can see that I have this TotalSim node that's being spawned up. The next thing that we need to do after spawning up TotalSim is to start our ROS-MCP server. So once we've started our TotalSim node, or this could be any node of your particular robot. In this example, I'm just using the most simplest TotalSim node. I will be able to do that. So the next thing that you need to do is you need to start up the ROS-MCP server. You make sure you have ROS-MCP server installed using the source. So, and this is the repository for the ROS-MCP server. You can clone this repository and follow the instructions for you to have it running locally. make sure that you install it. I already have the server with me. So as you can see that this is the server that I've cloned, and I made sure that the dependencies have been installed. Once you've cloned this and followed the instructions in the repository, or you can also take a look at the video that I've made before this. I'll give a link to the description box below. You'll have to start the server. So by default, the server gets started using the stdio transport mechanism, but we would not like to use the stdio mechanism because the client is not running locally on our computer and we're not giving commands using the terminal. So we'll actually be using the http streamable transport protocol in order for us to communicate for this, and make sure that you can use this particular command where you start the server python3 server.py, and make sure that you give the arguments of the transport as streamable http, and the host is 0.0.0.0. So this allows all the hosts to be able to communicate, and the port is going to be 8080 because that's the port that we forwarded using ngrok. So you'll be able to use that as well. So once you have this command, you can start the server. So I'll start the server, and as you can see that it should show me that the app has now started, and it is using the streamable http protocol for the transport mechanism. All right, so that's great. So now we have our server ready, and we also have our robot node running. So the last thing that we need to do for us to run this is to start a ROS bridge. Now the ROS bridge will communicate from the signals getting from the WebSocket over to the ROS, because it can't communicate directly. We'll have to make this bridge. In case you do not, make sure that you install the ROS bridge server for this, and you have the latest versions of it. So we'll do just that, and I already have it installed. In case you do not, you can follow this command and be able to install it. So I already have it, and I will use the following command to launch the ROS bridge server. And as you can see that it's a launch file, ROS2 launch, a ROS bridge server, ROS bridge WebSocket launch.xml. So this will allow you to launch the ROS bridge server, and once you hit enter, it should start, and it has started on port 9090. All right, so that's great. Make sure that you do not have any errors. In case you face any errors, you can update this as well. So I did face a few errors in the beginning, but they gone away when I actually updated it. So you can update it. So the command for updating is going to be sudo apt update, and sudo apt update ROS humble ROS bridge suite. So you'll be able to update the ROS bridge suite, and once you have that, you shouldn't face any errors after that. All right, so that's great. Now we have everything running on our computer for us to start operating on the total sim node that we have it here. So let's start giving it commands from N8N and see how it operates. So this is my chat. So this is my N8N workflow, and I would like to start giving commands here. So I've given it a command that make the total move in a square trajectory. So as you can see, the model is running, and then it has called the tools. And I will just quickly come here, and as you can see that the total has started to move in a square trajectory, and I can clearly see the communications that have been happening from N8N to here. And it has now been closed. We've gotten a response back from the server as well, and this is the final response. I think one of the use cases that you can also try to do is that remotely you can see what topics are available, how do you operate on it, and you can check from, like for example, I can also see what topics are available, and I will be and it will be able to start executing. Yeah, so as you can see that these are all the topics that are available right now in my current ROS workspace, and it has given me a good list of that. So I think that's it. That's it for this video. I hope you like it. Thank you so much for watching the video. I hope you have a nice day. Bye.